Hello, my Calc 3 student. Today we covered section 15.4, a study Green's theorem. This is our last section, what I want to cover it in our Calc 3 class. We did it, we great. And we start. Curve. Oh, just a moment. I don't know what happened. No, I don't need black. I don't need blue. I want R curve RT XTI plus YTJ. When T changing from some A to B, we call simple when it does not cross itself. This means RC not equal RZ for any C not equal Z from interval AB. Okay, doing some example in the picture. Any kind of this one, it will be simple. Or simply. And any type of something like this, you see, intercept, it's cross itself, or any kind of with holes, two holes. This is both of not. And now we have some Green's theorem. Green's theorem who tell us R will be simple connected region with piecewise smooth boundary C. This means C is boundary. Boundary. Curve. Orientated. This curve orientation, it will be counterclockwise orientation. What does mean counterclockwise? If you're moving for your curve and counterclockwise, it's always your region is left from your moving. Okay. If M and N have continuous first partial derivative is open region contained R, then we have integral from curve C m dx plus n dy will be equal integrals for region R dn dx minus dm dy dA. I not prove theorem here because you have proving in the book and you can easily see. If you have any question, ask me tomorrow in our office time or Friday. And then we have example. Oops. Example 1. Tell us how we can found integral for curve C if you have y cube dx plus x cubed plus 3x y squared dy, whereas your region is between y equal x cube and y equal x. And you remember we have counterclock orientation. This means I have something like this and this. Okay. This function y cube, it will be m. Function, it will be n. Now we start counting. Partial derivative dn dx, it will be 3x squared plus 3y squared, and dm dy give me 3y squared. And how you remember in use green theorem? Okay, this is integral. When we need counting, it will be integrals for this region R. We need subtract dn dx, we subtract the m dy. This is 3y cancel it, and this means I have 3x squared dA. Now we need to remember how if you're looking for our region, what you have here. Interception point is 1. This means x changing from 0 to 1, a y change from piece of parabola, piece of curve y equal x cube, and line y equal x. Okay, this means here I can move to my double integral to integral, whereas x change from 0 to 1, y change from x cube to x, 3x squared dy dx give me integral 0 to 1. If we integrate for y, it will be 3x squared y from x cube, okay, x dx. Let's give me 1. Oh, maybe 3 we're doing out, and it will be x cube times x squared times x is give us x cube, and x squared times x cube, it will be x to 5th. X, it will be 3 times x to the 4th over 4 minus x to the 6 over 6. 1 4 minus 1 6. It will be okay. I think it will be 3 minus 2 over 12. It will be 1/4. You can easily evaluate yourself. Okay. Okay. One more example. Let's go. We have integral from some c, y cube dx plus 3x y squared dy, and for our region we know it will be some x y, it's some good enough, some this kind of curve. Okay, and it will be opposite clock rotation. But if we start checking our function, what you have? dn dx, it will be 3y squared, and dm dy, it will be 3y squared. This means if we subtract 3y squared, we have 0. And double integral from 0, it will be 0. Not depend what kind of curve you have, what kind of region you have. Okay. No, it's depend. This means we can use green theorem, but after it's not. It will be 0. Okay, one more example. Let's go. We have integral from some c, arctangent x plus y squared dx plus e to the power y minus x squared dy, and our region is, maybe I put here, it will be, you have half of circle radius 3 and half of circle radius 1, and the region will be between. This means what you have here, and this is your orientation. Okay. What we have here, we need first found dn. No, I write dm, okay, no problem. dm dy who give me 2y, and dn dx who give me minus 2x. And this means my integral, I write star here, I can continue, it will be dn dx minus dm dy, double integral, this means minus 2x minus 2y dA for region R. Because region, we have region for this situation is something between two circle, it's much better move to polar coordinate system. If we're looking, because R change between, because this is between two circles, this means R change from 1 to 3, and because we have half of circle, this means theta change between 0 and pi. Okay, and here we can rewrite like theta between 0 and pi, R change from 1 to 3, and now we have, we can plug in minus 2 in the front if you want. Axis will be R cosine theta, y is will be R sine theta, but because I moved to new variable, we remember our Jacobian for this situation is R d theta. Here we have minus 2 integral from 0 to pi, integral from 0 to 3, R square, 1 to 3, what I write was 0 to 3, 1 to 3, automatically. This means here I have cosine theta plus sine theta dr d theta. Integral for R give me R cube over 3. Cube over 3. When you have from 1 to 3, cosine theta plus sine theta d theta. Okay, if you plug in 3, we have 27 over 3, it will be 9. This means minus 2. 9. If you plug in 1, you have 9 minus 1/3. Okay, great. Integral from cosine is will be sine. Integral from sine, it will be negative cosine. 0 pi. And oops, here is will be, I don't need this line, we need only checking. Okay, finally we have 27 minus 1, this will be 26. 26 times 2, it will be 52. Okay, minus 52 over 3. Sine pi and sine 0 is 0. Cosine pi negative 1 and cosine 0 is 1. This means in counting all this, we have negative 2. And this means I have 104 over 3. Okay, great. Now solving couple of question is similar your homework question. For example, number 6. Not 6, 16. It will be number 16. When you have, we need to evaluate 2 arctan 10 y over x dx plus natural log x squared plus y squared dy. And here is our curve C is x equal 4 plus 2 cosine theta, 4 plus 2 cosine theta, and y equal 4 plus sine theta. Okay. Now this means we have some ellipse here. First, remember this is m, and this one is n. The m and the y will be twice derivative arctangent is 1 plus what you have inside arctangent square. And derivative y over x is will be 1 over x. If we simplify, it will be x squared plus y squared. Then x squared go to up and cancel it, 1 of x. It will be here. Now we need found dn dx. It will be natural log. This means here we have x squared plus y squared in the denominator, and derivative of x squared plus y squared, it gives us 2x. We see this is 2 derivative is equal. This means if you take it integral, move to integral, double integral, you have 0 there. Okay, great. One more example. What happened if you have some inside your region hole? Number 18. Oops, 18. We have I think about region and start write R. C. Number 18 here. E to the negative x squared half power minus y. This is dx plus e to the negative y squared over 2 plus x, that's dy. And region is 1 curve is x equal 6 cosine theta, y equal 6 sine theta, and second x equal 3 cosine theta, y equal 2 sine theta. How you can easily see? First one, it will be x squared plus y squared equal 36. This means circle with center in origin and radius 6. And second one is will be x squared over 9 plus y squared over 4 equal 1. This means ellipse. Okay. If you see here, it will be, okay. Let's go, this is circle, and this is minus 6, and here is 6. And we have ellipse, where it will be, here is 3 and 3, and this will be, if it's, here is 2, here is 3, this means something like this. And our region between these two curves. Okay, first found derivative here, partial derivative. This means dn dx. It will be exponential function depend only y. This means you don't have anything. And take a derivative x for respect x is give us 1. dm dy. Here you have exponential depend only x. This means 0 and minus y. It will be negative 1. This means our integral now is equal origin. If we subtract 1, subtract negative 1, you have 2 dA. Here you have 2 origin dA. This means here we need solving. We need found area our region. It's it. Double integral here. It means our area our region. If area our big circle is no problem, we need only found area our ellipse. Okay, what we have here? We have integral, double integral. How is changing x? X change from negative 3 to 3. I'm doing twice because I'm looking part half of ellipse. And how changing y? Y change from 0 until this curve. A curve will be 2/3 square root 9 minus x squared. And then we take it dy dx. It will be twice integral from negative 3 to 3 y dx, where is y from 0 to 2/3 square root 9 minus x squared. It will be 4/3 negative 3 square root 9 minus x squared dx. And for this situation, we know our integral is 1/2, but I use 1/2 and this will be 2/3 here. X times square root 9 minus x squared plus arc sine x over 3. And changing from negative 3 to 3. Okay. what we have now? If you plug in 3 and negative 3 for first term, for both of and both situation you have 0. Plug 3. Arcsine 1 is will be pi over 2. This means 2/3 pi over 2. Arcsine negative 1, it will be negative pi over 2. This means you subtract negative, it will be plus pi over 2. And finally we have 2/3 pi. And our integral, when we need count, remember it will be after we have, it will be 2 area our region R. Circle give us, because radius is 6, this means it will be 36 pi. Here it will be minus 2/3 pi. It will be finally 9, 108 minus 2, 106. 2 times 106 pi over 3. Okay, this means if I'm not making arithmetic mistake, we have this kind of answer. One more example. Number 24. You have vector fields f y, who is equal 3x squared plus y, I plus 4xy squared, 4x y squared j, and your region is something between y equal square root of x, y equal 0, and x equal 9. Okay. And you need found work. Work, this means we need found integral our force, vector force, for this curve. Okay. Well, first we need prepare our integral. First looking for our region, what we have here. Square root of x, it will be something like this. Y equals 0 is x axis, this is y axis, and x equal 9 is vertical line. Oops. This means here we have something like this. This is 9, the square root of x. Okay. Now we need counting what this will be. Dn dx. It will be 4y squared. Dm dy. It will be, how I think it's only 1. And this means my work will be double integral for region R, 4y squared minus 1 dA, which give me x changing from 0 to 9, y change from 0 to square root of x. Here we have 4y squared minus 1 dy dx. Give me integral from 0 to 9. It will be 4/3 y cube minus y 0 square root of x dx. 0, 9. Plugging square root of x, we have 4/3 x power 3/2 minus x power 1/2 dx. I think this writing is more useful. If we integrate, this will be 4/3 x, new power, it will be 5/2 divided by 5/2 minus x to the 3/2 power divided by 3/2, 0 to 9. Continue. It will be 8/15. 9 to the power 5/2, it will be 3 to the 5th power, it will be 243. 243. And minus 2/3. Here is only 27. Okay. And I use calculator here. It will be 111.6. Okay, guys, I think we work very well all semester, and for online part we have not so much more so big numbers material, and we covered Green's theorem. This means we finish all our work. How it works next semester, next week. Next week we prepare for final, and Monday you have one more quiz, last quiz, and then see if you read my letter about how it will be final. If you have any anything what you're thinking about final, write me. And tomorrow, remember, tomorrow we have office hour, and Friday we have office hour too. Okay.